Hello everyone, welcome back to another video of Statement List PLC programming. And in this video we talk about the flag control instructions and how they are used. The first instruction we will talk about is the NOT instruction. It is a simple instruction that just negates the value of the RLO. So if RLO was 1, it changes it to 0. And if it was 0, it changes it to 1. So let's look at this example. And here, if we have both inputs are 0, the RLO right before the NOT instruction becomes 0. Then, the NOT instruction changes that value to 1. And our result becomes 1. Now if both inputs are set to 1, RLO here should be 1. And then the NOT instruction sets the RLO to 0. So that's how it actually works. But when should you use that NOT instruction? You can basically use it in order to implement something that is normally closed in your program. Now, the second instruction in our video is the SET instruction. Basically, all that instruction does is set the RLO to 1 unconditionally. The CLR instruction does the opposite of that. So let's see an example on those two instructions. So basically, here if you look at the value of the RLO before the SET instruction, it was 0. And after the instruction, it becomes 1. And our output is set to 1. The same happens with the CLR instruction. So here we change the RLO from 1 to 0. And our output here should be 0. You should also note that unlike the SET instruction, the CLR instruction reflects 0 in the status bit, which we see while monitoring our program. Now let's talk about the save instruction. The save instruction basically saves the value of the RLO bit to the BR bit. But is this actually useful? The answer is yes. It is indeed quite useful, and we will explain that now. First, it is used to make the BR act as an error flag. So let's see how. In this example, suppose that the user has to enter a value. This value will then be compared to 100. And if the value is less than 100, the output will be changed to that value. However, if the value is greater than 100, output should not change. So let's actually try that. And we put our input value as 30. So output is changed to 30. Now say the input is 150. The output will remain at 30 and won't change. To understand that example, let's go first to debug mode. To understand that example, let's go first to debug mode. And we place a breakpoint here. And now if we execute our first instruction, RLO should become 1. Then, the second instruction copies the value of the RLO, which was 1, to the BR bit, which is what we see here. Now we come to our comparison. So we load our input. And we load 100. Then, we use a comparison instruction. And all that compare instruction does is change the value of the RLO according to the comparison result. So if the input is less or equal to 100, RLO will be set to 1. However, if it is greater than 100, RLO will be set to 0. In our first case, the input is 30, which is less than 100. Therefore RLO should be set to 1 after that compare instruction, which is what we see here. And then we come to a jump instruction, which is the JCN instruction. That instruction looks at the value of the RLO. And jump action happens only if the value of the RLO was 0. Skipping the output change instructions, which are those two. And continuing at this label. Which leads us here, where we again reset the RLO. And save it to the BR with another save instruction. But for our first case RLO was 1, so no jump action will happen and execution will continue. Our input is loaded again, then transferred to the output, which is what happened here. And then RLO is reset with the clear instruction, as you can see here. Then again the RLO is saved to the BR bit and it changes to 0. Now for our second case. So first let press continue. So we are back here at our breakpoint. And let's change the value of our input. Say now our input is 150. First we have set. Then save. Loading the values. And because 150 is greater than 100 RLO, after that compare instruction will be 0. Now, here jump action should happen because RLO is 0. And code continues at that label, skipping the assignment section. Therefore output will not change in that case. And as you can see, the value of our output is still 30. Then we have our clear instruction. And finally, our save instruction. So what happened here is actually that we controlled the program and prevented it from using a bad input. And kept the recent healthy input value as our output. All of that with the help of the BR flag. When it was 1, that was our healthy case. And when it was 0, that was our error case. And a jump happened and we skipped that part. So that example showed a very useful case where we have to use the save instruction and the BR bit as an error mechanism. Now let me add that. Note for any ladder code that has this ENO mechanism, which you will of course see everywhere in your ladder code, that the save instruction and the BR bit are how this functionality is implemented. To show you how, we need to first cover the jump instructions, which we will do later in that course. But just sleep on that note for now, we will explain it later in the course. And with that said, we come to the end of our video, and in the next video we should discuss the edging instructions, which will be our final video in that section. If you have any questions, please post them in the comments. And please like and subscribe to the channel.